My name is Yoichi, and today I'm going to talk about dependency injection. Before that, let me introduce myself. I'm Yoichi again, and I'm from Tokyo, just the day before yesterday. And this is a photo of the Tokyo evening view. It has a lot of buildings, some parks, and Tokyo Tower. Do you have any object that you like here in this picture? Personally, I like this building because I work here at a company called Mercari. It is one of our diversity sponsors of this conference. And yeah, as introduced at the beginning of my talk, I'm the original author of Swinject, which is the dependency injection framework for Swift. Now it's maintained by 5 people, recently especially by Jacob Vano. And it has more than 2,000 GitHub stars and 1,000 clones every day. And it has 4 extensions provided. So this is today's agenda. I'm going to talk about software architecture, then dependency injection, after that Swinject as a DI container. So what is software architecture? It's actually a difficult question because a lot of people say, oh, this is architecture, this is tech architecture. A lot of definitions are made by a lot of people. So here is a good article written by Peter Ellis. This is actually written about 10 years ago, but still it's really worth for reading to know about software architecture. He says, an architecture defines structure and behavior, as you know, as architecture probably. Also focuses on significant part or significant element in the system, not tiny things, as you know. And the architecture may conform to our architecture style, like MVC, MVVM, or maybe Viper, as you know. And the fourth one is an architecture influences team structure. This is also known as inverse Conway's maneuver. Maybe some of you guys know about this. But important things, 3 important things about architecture, he says, are like this. An architecture balances stakeholder needs. It's like not only engineers, but also users or business owners. And also, the architecture is influenced by the environment you have. Like at the beginning of the launch of an application, or time goes by, the environment will change. And also, the architecture embodies decisions based on rationales. So there is no single solution of architecture. So each of your application or company or team has the good architecture for yourself. So it's your decision. So architecture is not static but dynamic. It's like over time, the situation changes. Like this, for example, at the launch of the application, it's 0 years from the launch. And after that, 2 years, 5 years, 8 years. The users might be like this. You have no users at the beginning of the launch of the application. But after 2 years, you might have 10,000 users. Maybe in 5 years, you have 10 million users. Maybe in 8 years, 100 million users you have. let's talk about engineers. Maybe at the beginning, you have only one engineer, maybe yourself only. But after 2 years, you have 5 engineers, and 10 engineers in 5 years, and 100 engineers in 8 years. How about architecture? So at the beginning, you might choose MVC because it's really simple. It's really fast to develop, to provide or launch the application with minimum variable set. And in 2 years, maybe you want to choose MVVM because you want to write some unit tests for view logics. In 5 years, you might want to choose Viper because you want to test for business logics. Because in Viper, the separation concern is really clearly defined. In 80 years, with 100, a lot of engineers, you might choose Rebus. Because in this architecture, you can split the big team into some small teams to get them take ownership. So the architecture is not static, but dynamic over time. So now, let's say you have a system that has 3 components, like A references B or using B, and B references C. But later in the future, you might want to change B to something new, like new B in this picture, or you want to split the C part into 2, or you want to add completely new one, like D. Not only the time goes by, the same thing is in the unit test too. Like in production, like you have like ABC like this, but in unit test, you want to replace B and C part with a mock stub of B to write unit test for A. So we need flexibility in your architecture. So how to make architecture flexible? So here it's dependency injection. Because dependency injection is glue, but it's sticky like glue. So if you use just normal, typical, strong glue, it's tight coupling. The coupled by the normal glue, it's really difficult to replace or change or tear away. But if you use sticky like glue, or just like sticky, it's easy to replace one sticky with another one. Or maybe it's easy to cut one sticky into 2. So it's loose coupling. It's really flexible. So dependency injection is like sticky. So how to make the sticky like glue in your system? So before talking about that, here is famous principles, like solid principles. I'm not going to talk about the detail, but it's abbreviation of the single responsibility principle, open-close principle, and risk-off substitution principle, and interface segregation principle. But here I want to talk about, or talk with dependency injection. It's the last one, dependency inversion principle, which means a system should not depend on concretion, but abstraction. So this is an example that depending on concretions. So if your implementation references a concrete type, it's a tight coupling using the typical normal glue, strong glue. But if your system is just depending on abstraction, it's like this picture, which means if your implementation reference is just protocol, which is interface, especially in other languages than Swift. So in this system, it's easy to change or replace one concrete type with another one, like sticky. But here is a problem, because the system cannot work only with abstractions. You need concrete definition of type to make your system work. So here we need dependency injection. It is a way to realize dependency inversion principle. And the way it works is easy. Just pass or inject instance with a concrete type into your implementation with your initializer. It's just dependency injection. With this injection, the system is configured to use a concrete type you defined. It's easy, right? So the source code is like this. So here, abstraction is like protocol. In this example, the protocol is API client protocol. And we have concrete type, like API client, conforming to the API client protocol. The dependency injection is like this. In the initializer of my view model, for example, we pass the concrete type, actually instance of concrete type like this, as an argument. And the type of the argument is actually abstraction, which means abstract type, like API client protocol. And the exact definition of the my view model here is like this. It has a stored property to have the dependency. Okay, so let's use Swinject here. It's a register and resolver style dependency injection container. It's like a dictionary. So how to use Swinject? It's really simple and easy. So first you register the dependency or dependency graph to the container. Then when you need an instance from the container, you just call resolve method to get an instance from the container. So code example is like this. So first you make an instance of a container. Then you register the configuration of abstraction to concretion. Like here, API client protocol will be resolved as concretion type API client. And then you are going to configure how my view model is instantiated with some dependencies. So here, first, the exact type of the API client protocol will be taken from the container. Here, the container is named as resolver in the closure. Then you pass the API client to the my view model, for example, here. So with this simple configuration, you get my view model easily. So this is how you resolve the dependencies you configured with the container. So it's just one line. So you call resolve method with the type you want to get from the container. So it's simple and easy, right? But it's a bit complicated if you have a production app. The dependency injection is like this, often in your production app. So the view model, or example, the class might have 1, 2, 3 dependencies, and also it might take some parameters to instantiate, like ID or name. So you get more and more dependencies. Time goes by, and it's unclear which part is dependency and which part is parameter, just parameters. So here is a practice to make it simple, using type areas of dependency tuple like this. So in this initializer, you pass just type areas, I mean a tuple of dependency, like D1, D2, D3. And you also pass some parameters like ID and names following the dependency. So in this way, it's really clear that what is dependency and what are just parameters. So this is some simple example to tell about the practice. The example just with 2 dependencies and 1 parameter. So you have 2 abstractions and concretions like this, API client logo. And example of the view model, you define type areas of dependency which has 2 elements in a tuple, like this. And add some stored properties to have the dependency and parameters. And the initializer is like this. So to register the dependency to the container, it's also the same way. So first register the abstraction and concretion to tell how they are resolved. So here is the configuration of the view model. So first you get the actual type or actual instance from the container, which is named resolver in the closure now. And you pass them to the initializer of the my view model, like this. To resolve the dependency, it's just 1 line, like this. Okay, so in this practice, it's really good to evolve the system over time. So let me summarize my talk. So first, architecture is not static, but dynamic to evolve as time goes by. And the second, dependency injection is like sticky like glue to make your system flexible. And using the type areas group dependencies is a good practice to make your initializer readable. Okay, thanks. Here's more information if you want to learn the dependency injection in iOS or Swift. Thanks for listening to my talk.